Okay, so in the previous video we talked about uh, how to do the nth roots of a complex number. So uh, in uh, write the number first in its polar form, and then it's all of the values zk, where it's nth root of the magnitude of our complex number times cis of theta over n plus 360 over n times k. Or if we're doing it in radians, it would be 2 pi over n times k. So here we want to find the square roots of I. We know that I is the square root of negative 1. All right, we know that I is a square root of negative 1. Take I and square it, we get negative 1. But what about the square roots of I? Well, first thing we can do is draw the complex number I on the real imaginary axis, real imaginary plane. And so I, of course, is right up there with a magnitude of 1, and it's 90 degrees or pi over 2 away. So we can write I down as 1 CIS 90 degrees. And so now we want to find the square roots of that. So to do that, we compute ZK, which would be the square root of 1 squared in the magnitude, CIS, 90 degrees divided by 2 plus 360 over 2 times k. We're dividing by 2 here because we're doing square roots or second roots. And so we simplify this. And we get 1 CIS. 90 divided by 2 is 45 degrees. 360 divided by 2 is 180 times k. So we get 1 CIS 45 degrees plus 180 times k. And so then we go through and compute our ZKs. So Z0 would be 1. So k equals 0. Of course, the 180 part goes away. We just have 1 CIS 45 degrees, which if your book asks you to put this in to that exponential form, which it sometimes does, and it may ask you to use radian measures when they ask you for some of these angles. So uh, for this, whether we use radians or degrees doesn't matter because we're going to compute cosine and sine of 45, and whether I write it as cosine of 45 or cosine of pi over 4 doesn't really matter. For the exponential part to be correct, though, that e to the I theta, that only works if the angle for theta is in radians. So when I write this in exponential form, I have to write it as e to the I times pi over 4, or e to the pi over 4I. So if I'm writing in an exponential form, writing that as e to the I times 45 degrees just doesn't work. Okay. There's a technical reason. It goes back to some calculus stuff of this relationship between e to the I theta and sine and cosine, but for that relationship, they have to be in radians for it to work. So if you're writing in an exponential, you have to use it in radians. For that reason, some of the book problems may require you to do it. But if we're working these out and computing them, it's not going to matter whether we do it in degrees or radians, because now we're just going to say, hey, that's just going to be cosine of 45. I keep hitting the wrong buttons, and I apologize for that. Uh, uh, keep hitting the wrong buttons here and messing everything up, so I'm sorry about that. All right, back to our problem here. That's going to be cosine of 45 plus I sine of 45. And then we compute that. Remember, cosine of 45 is just square root of 2 over 2. So that's going to be square root of 2 over 2 plus square root of 2 over 2 I. If you take that thing and square it, multiply that times itself, you will just get I. back is your answer. Of course, we can see that. If we take and square this in its trig form, that would just be multiplying the angle by 2, which would make it 90 degrees. And we'd have CIS 90 degrees. So then we go down and we talk about Z1. That's going to be CIS 45 plus 180 times 1. So CIS 225. Again, if you're doing an exponential, you'd have to write the 225 in radians. That would be e to the I pi times 5 pi over 4, or e to the 5 pi over 4i. You can write it either way. And then to work it out, we would just do cosine 225 plus I sine 225. And then we just compute that. 225 is in the third quadrant with a reference angle of 45. So that's just going to be negative square root of 2 over 2 for both of those. And so we get the answer negative square root of 2 over 2 minus square root of 2 over 2i. And the last thing I wanted to show you here was the graph. So I've made this kind of small, but you can see it here at the bottom of the screen. There's your first complex number, square root of 2 over 2 plus square root of 2 over 2i right here. And there's the negative 1. You can see, of course, being square roots, they're separated by 180 degrees. They're on opposing sides of the circle.